Good day friends, Given here from Techno Drive. Welcome back to the channel. Today we've got another inverter. It's a Luxpower SNA5000. So this is a 5 kilowatt inverter. So the problem we are having here is that it's pulling too much current before you even turn it on. So basically it's not switching on from the battery. So it's drawing all the power from the battery. But the moment you connect the AC, the inverter comes on. So it's a bit tricky. I'm gonna work with you so that you can see what's happening here. Okay, so this is the inverter. So when I check with the multimeter, let's check and see how much resistance we are getting there. You can see that I've got 16 kilo ohm resistance. So that resistance is dropping the current. Let's connect. I've got another inverter that's working here. This is another inverter. This one is working. When you connect the DC, let's check the resistance there. We're just gonna measure and compare. You can see this one is giving 20 kilo ohm, but the inverter is working. Let me show you the current that the inverter is pulling when on the working inverter. So this is what we need to check, because the resistance is not that much different. That one is 16 kilo ohm. This one, the working one, it's 20 kilo ohm. But there is a problem because the other one is pulling the power. So let's put it on amps. I'm gonna connect the amp meter. Okay, I've got the amp meter ready. You can see that I've got the 0 amps there. So here is our power supply. So let's see how much current we are pulling when the inverter is coming on. Okay, I'm gonna connect. Okay, there we are. We've got 0 amps, like 0.18 amps. Let's switch it on. 0.19. See, now we're pulling 100 milliamps. So the inverter is now on, as you can see on the screen. It's just 0.14. Okay, the inverter is switching on. You can see now we've got the AC power, but we are pulling 1 amp only. You can see the inverter is normal. We've got 230 there. We're just pulling 1 amp. So this is a healthy inverter. The inverter, when it's on idle, when there's no load connected, it should pull just 1 amp. Not 2 amps, just 1 amp. Can have 1.5 amp, or depending on the type of inverter, but it shouldn't be more than that. So the inverter that's broken underneath there, it's although the resistance is reading 16 kilo ohm, but it's pulling more than 1 amp when it's on idle. So that's a big problem. That's what we need to sort out. Let me connect the other inverter so that you can see what I mean. I'm gonna disconnect this one, and then we connect the other one. Okay, this is the inverter that's broken. It's not switching on when you connect the battery. You remember the other one was drawing 1 amp on our amp meter there. So I'm going to connect this one so that we can see what's the difference. So on my bench here, I've got a 5 amp power supply. Let's see what's happening. What current are we pulling here? Okay, it's even sparking. Okay, you can see that we are pulling 5 amp. So that's the maximum power that the power supply can push. So the other thing is this inverter, it comes on when you connect the AC. You can see I've connected the AC, the ESCOM line there. Okay, let's disconnect the battery, because it's just pulling power for nothing. Disconnect. You can see that it's coming on with the AC. I've just plugged the AC. You can see the inverter, it's on there. the inverter is on, but this inverter, it will never work because you see there's error 17 there. So this error 17, it will not allow the inverter to work. Okay, so what is error 17? So you can see that on the manual here, it shows that E017, which is the error that we are seeing there, is the internal communication fault. So this communication fault is causing the inverter not to function properly. So we're just running with the AC, so you're gonna obviously have that problem. So once we connect the battery draws too much current and it's not even switching on with the battery alone. So this inverter is not right. So obviously most of the boards inside, they are not supplied with power because some of the power will be coming from the battery. So that's why you are having that internal communication. Some of the sections then don't have power, so there won't be a communication inside. So you're gonna have that problem, and the inverter will not work. Here they say restart the inverter. Even if we restart it, obviously it will never work because there's a short on the input. So the inverter is pulling too much current than what it should. So let's try and fix it. Let's see what we can do here. Let's disconnect the AC. Okay, now we are going to strip the inverter, then we can see what is wrong. Okay, I've got all the screws removed for the cover. Let's remove it. Okay, here's the control board. It's removed now. So now we can remove the MPPT board. Here we are, we got the board removed. So we are going to do some final tests before we can remember we're getting higher resistance, but there's measure with the multimeter the resistance. I'm not getting a short circuit. I'm getting 20 kilowatts. So you can think that this inverter is working, but it's not right. So let's check the MOSFET, the IGBTs and all other things to see why are we getting this. This is strange. here is our MOSFETs. So this one is using bigger input MOSFETs. So we have to check those. And see if there's so these are the low voltage MOSFETs. These are the IGBTs. These are the IGBTs. Okay, so this pair is okay, this pair is okay, so this pair is not okay. So the second and the third pair are not okay on the low voltage. That's why we're getting that high current on the battery terminals. Let's check the output IGBTs. Okay, the output IGBTs looks okay. Okay, so I've tested the output stage IGBTs and the MOSFETs. So it looks like our problem is on the MOSFET side. So because there's a short on some of the MOSFETs. So we're going to remove all of these MOSFETs and check if there's no damage on the driving side. And also the IGBTs I've already tested, they're okay. So these ones we won't change anything. So let's remove all of these MOSFETs, and then we can test the inverter. Okay, I've just removed all of the MOSFETs. You can see the holes there. I'm sorry I didn't show you on the video, but if you want to see how to remove MOSFETs, you can check on previous videos. So what I've seen is that the driving circuit as well is not okay. So some of the resistors here, they are not reading okay. They are not right, they are bent. So let me take it to the microscope so that you can see what's happening. Okay, I've got the board on a microscope. So let's check the driving resistors because that's most important. R205, this is the first IGBT Q51. It's gone. Okay, let's go to the second one. This is the second pair. You can see it's gone there. So let's go to the third pair. 30 ohm. And that one is bent. So we have to change both. So let's go to the third one. So in short, all of the driving IGBTs needs to be replaced. So you can see all of them, they are bent. So the quickest way to fix inverters is to make sure when you change the driving resistor, don't leave the optocoupler. That's very, very critical. Because if you leave the optocoupler, you're going to have endless problems. Let me show you why I'm saying that. It's because you see this 30R0, this 30 ohm resistor. This one's, since one pair it's connected together, since two IGBTs are connected together, This one goes to the gate of the other IGBT. You can see if you follow it, there is the gate, and the other one goes to the other gate. So it's actually one MOSFET, but they've combined them. You can see this one, 30 ohm. If you follow it, it will take you to the other gate. So this is the gate of the MOSFET. So it's bent. So what's happening is these are connected directly to the optocoupler. So the resistor is bent. So what about the optocoupler? We can't see inside the optocoupler. So we have to change this optocoupler. Otherwise, we're going to have endless problems. So we definitely have to change these resistors and all of the optocouplers. So that's what we're going to do now. I'm going to change all the optocouplers and change the resistors. Okay, we have removed all of the optocouplers. So this is what I was doing under the microscope. You can see the optocouplers here, they are. I'm going to put new ones on the board. I've also changed the surface mount resistors you saw there. So this is the reel that we use. So this is full of those SMD resistors. So I'm going to change the optocouplers now. So the optocouplers I can use even the soldering iron. So that's why I took the view to this side. Let's replace the optocouplers. So normally what I do, I replace the optocouplers with the TLP352. Those are the good optocouplers. They are high voltage optocouplers. So these are the optocouplers. Okay, all of the optocouplers are replaced. Now it's time to change the MOSFETs. I'm gonna put new MOSFETs. Then we can test this inverter. Okay, our board is cleaned. All MOSFETs are replaced, optocouplers replaced, driving resistors replaced. Actually, the whole primary stage has been repaired. So let's now test the board. You remember it was pulling high current when we connect the DC. Okay, I've got the current meter ready there. And also I've got the multimeter. The multimeter will help me to see if there's voltage coming in, because you remember the moment you connect the battery here, it was going down to like 0 volts and pushing about 5 amps. Let's connect it now. You can see we are drawing only 30 milliamps. So this is good. This is good, because the inverter is not on. Once the inverter comes on, then it will go up to 1 amp when the inverter is working. So you can see that I've got 50 volts on the multimeter here. There's 50 volts and there's no short circuit. So those input stage MOSFETs were damaged. Okay, let's put the board onto the cover, and then you can see if it does indeed give a voltage. Let's do that now. Okay, yeah, I'm sure we are now happy. Let's assemble this inverter, then let's see if we do have power indeed, because now we don't no longer having a short there, so it should be okay, it should work, but you will never know. Let's assemble it and then we can run it. Let's connect the power and the moment of truth. Okay, we are drawing 0.27. There, the inverter is on 0.14. So the inverter is still not right. Okay, but before we can change the MPPT, I'm thinking maybe the MPPT is working, because this MPPT it's supplied by this bus voltage. So we have 400 volts coming in. So that switch mode power supply there, it's going to regulate the voltage to around 5 volts and 12 volts for all of these small capacitors here. So it could be that the board, since it was faulty, maybe the bus voltage is not there. Let's check if there's a bus voltage. So we have to check if there's bus voltage before we can replace the MPPT. Let's connect there, negative, positive. This is going to my multimeter. This is 400 volts. Just make sure it doesn't short. This is a very high voltage. Okay, there is my multimeter there. Okay, so on the multimeter, I'm going to read the bus voltage, if there is a bus voltage. You can see now, on my multimeter, I'm reading 0 volts. There is 0. So let's connect the power again. Yeah, Luxpower, it's troublesome. Let's see. Okay, the inverter is coming on. But the bus voltage is not coming up. There's nothing, it stays at 0. So that's the problem. So it means that the MPPT board is okay. Alright, what we're gonna do now, let's switch it off. Yeah, there's still a problem with the board that we fixed. So the problem is still inside the board. So what we are going to do, let's test if the MPPT will come on with an external voltage. That's another way of testing. Okay, yeah, with me here I've got 200 volts test voltage. Let me connect it so that you can see, because this MPPT can turn on even if it's 200 volts. Let's check my meter with my meter. You can see on the meter I've got 203 volt DC. Okay, so this is DC, it's not AC. If you connect AC, you're gonna blow the MPPT. So let's connect it on the DC bus If the light comes on, then the MPPT board is okay. So I'm going to connect it on the DC bus terminals. This. Okay, see the MPPT board is on. So the MPPT doesn't have any problem. I'm sure you can see the light there. See, I'm connecting 200 volts and there's light there. So the MPPT board is okay. We have isolated. So what now is, it's a problem, it's the board that we just fixed. So we have to strip it again, then see what's happening, what's wrong. So we have to find out the problem. Not an easy one, but we have to do it. Let's remove the board again. Now the short is no longer there, but the DC bus is not picking up. And if the DC bus is not picking up, the MPPT board won't work and there will be internal communication error. Okay, here is the board. The question is, why are we not getting the bus voltage? You can see these terminals, these wires. These are the ones that goes to the MPPT. And we need that 400 volts. We are not getting it. We are not getting the 400 volts. So we have to check if these optocouplers, they've got power, because that is the most important thing. These MOSFETs, they change the low voltage 48 volts to 400 volts, which is our bus voltage, and that voltage goes to the MPPT. Do we have power here? Is there any short? Let's check all of these capacitors. Let's check and see if we have any problems here. Let's see. So the capacitors are reading like 12 kilo ohm, which is okay. Let's check here. I'm not happy with this capacitor. 400 ohm is too low. Oh yeah, it was charging. Let's see. No, it's not. It's a very low resistance. So what does this mean? Let's see this one. So this one looks okay. So this optocoupler capacitor has got a low resistance, 400 ohms. And this one, okay, that one is picking up. Let's check this one. Low resistance. We've got an issue here. Two optocouplers are reading low resistance. So where could be the problem? So we have to check these diodes and Zener diodes. Most importantly, the Zener diodes, because they are the one that supplies power to the optocouplers. Okay, I think I found the Zener diode that's giving a problem. It's this diode here. It's not reading okay. So I'm gonna change it. It's a 15 volts Zener diodes. Okay, I've just replaced the Zener diodes as you have seen. Now I'm going to check if the voltages are okay on all of the optocouplers. We should get 5 volts and 15 volts on each optocoupler. There is the first capacitor, 5 volts here. Oh, it's not plugged in. We plug the board in. You can see that the board is manually switched on there, so it's already on now. Let's check the voltages. Okay, there I'm getting 5.7. 15 volts, it's okay. So there's no more short. 5.2. 15 volts is okay. 5.4. 15 volts is okay. 5.7. Okay, and 15 volts. So all of the MOSFETs are getting power now, and then it should be okay. Let's test it and see how it goes. Okay, we have checked all of the voltages and the board looks okay. So now we are going to install it back. Then you can see this board is been worked so hard, but it will come right. It will come right. So it's just that with the Luxpower we can't test without the coils. We won't have an AC output. So we just have to connect everything. So that's what we are going to do now. Yeah, we have to test it and we have to hope for the best. Let's put the display here so that we can see what's happening. Let's put power. Let's see. Okay, there the inverter is coming on. Okay, we can see that we've got a bus voltage, the MPPT is on, and there is an output 230, but we are having error 15. Let's go to the manual and see what's error 15. Phase error in 3-phase. So it's just the settings, this one. So it means that the inverter was set to run in 3-phase, but now we are running only single phase. So this is just a setting, error 15, phase error. That's not a big problem. But we are happy because we've got an output there. See that 230? That's what we wanted all along. We really needed that voltage. So we've done a lot on this inverter to get to this point. We are now done with the repairs. I hope you liked the video. I hope you've learned something, and hope to see you in the next one. Thank you very much, and thank you for watching. We've got voltage. Check there. UPS enable 230. That's our output. We are sorted now. We are happy. Thank you very much. Thank you for watching. We've got DC bus. The MPPT is flashing. Everything is okay. Hope to see you on the next one. This was not an easy one. It's not even easy to end. But I'll see you on the next one. Thank you. Sharp, sharp.